Hey guys, we're going to go over the Common Assessment 2 review quiz. Once again, I just want to advise you to fast forward through parts you understand or repeat parts that you don't understand. Those of you that are really struggling with math, I would go through these videos at least twice, okay? And also see if you can rework the problems, like erase them or put your hand over them and then see if you can figure them out again, okay? All right, so let's go ahead and start with number 1. We're going to fill in what kind of angle is a linear pair. Now, one way you could possibly think about this, linear pair, I know that we say that linear pairs are side by side, and some students are still having trouble understanding that. So imagine linear pairs are always at the same intersection. So if we have angle 2, it's not going to be a linear pair with any angles in this other intersection. Okay, imagine like angle 2 and angle 4 are holding hands, angle 3 and angle 4 are holding hands, angle 1 and angle 3 are holding hands, angle 1 and angle 2. Okay, if they're holding hands, they're linear pairs. They're side by side, okay? So angle 2 and angle 4 are linear pairs. But angle 2 and angle 1 is also a linear pair. So either one of those answers would be correct. Let's go to number 2. Angle 7 and angle blank are vertical angles. Well, let's go to angle 7. Now, angle 7, if you think about this, it's linear pairs with 8. They're holding hands, you can say they're side by side, and 7 is side by side with 5. You can say 7 is holding hands with 5, 5 is holding hands with 6, and 6 with 8. Now, 7 is not holding hands with 6, they're across from each other. So this is what we mean by a cross. Alright, so, which means these are vertical. So 7 and 6 are vertical. Alright? Okay, now angle 5 and angle blank are same side interior. So let's look at the interior. If it helps you, draw your own angle or your own parallel lines cut by transversal. And you can see which angles are the interior. So 5 has to be interior with one of these 3, 4, and 6, but the same side of, which means same side of the transversal. This is your transversal, okay, P, we should say P there. Alright, so this is your line A and line B. So, same side interior angles, so this 5 is the same side of the transversal P as 3, and both are interior, so 3. Alternate exterior, so angle 2 is exterior. Now, if we want to do alternate exterior, it can't be in the same box. It's got to jump here. So which angle is it? Because there's only 2 other exterior angles. It's the one on the other side of the transversal. If it was here, these would be same side exterior. So alternate exterior would be here. So angle 7. Okay, let's go on to number 5. We're using the same diagram. Angle 5 and angle 4. Let's see, angle 5 is jumping to angle 4. These are both interior angles, and on opposite sides of the transversal, these are alternate interior. Okay, angle 4 and angle 1. Now these are in the same intersection, and they're not holding hands, they're across from each other. Those are vertical angles. Okay, angle 1 and angle 8. Now these are both exterior, okay, and they're on opposite sides of the transversal. They're not in the same box, so this is going to be alternate exterior. Now let's go to angle 6 and angle 8. These are in the same box and they're side by side. Look, they're like kind of holding hands. That's a linear pair. Now none of these have corresponding angles in them, so just as a quick review, corresponding angles. Okay? Make sure you review not only corresponding this sheet, but you should be reviewing some other things, and I'll outline that on eClass, what else you should be using as a review. Okay, so corresponding angles. For example, angle 1. Which angle is corresponding with angle 1? Well, it's none of these angles at the same intersection. It needs to jump the other intersection to the other intersection. But then which angles does it correspond with? Well, corresponding means basically same position, different location. So if you look at angle 1 here, it is in the box, it's on the top left part of the box, okay? Angle 3 is on the top right, angle 2 is on the bottom left, angle 4 is on the bottom right. So if this is on the top left, let's look for the angle that's in the top left. So here, top left, so it's angle 5. Okay? For example, angle 3 is corresponding, this is top right in the box, so angle 7 is top right in the box. Bottom left in the box, that's angle 2. Well, which one's bottom left in this box is angle 6. And then you have angle 4 corresponds with angle 8, because angle 4 is on the bottom right, which corresponds with angle 8, which is on the bottom right. Alright, that's just a kind of refresher of corresponding angles, since I don't see any corresponding angles here. Let's go to number 9. Now number 9, you're going to use the exterior angle theorem. Exterior angle theorem. Okay, so why? Because I see an exterior angle here. And remember, exterior angle theorem says remote interior angle plus another remote interior angle is equal to the exterior angle. Okay, so angle, angle. So if you look here, this is a remote interior angle when you look at it in terms of this exterior, and this is remote. Okay, remember the two remote interior angles add up to be the exterior. So if you already have the exterior, one way you can think about it is this is an x. So if it helps you, you can say, okay, this x plus 50 should equal the exterior. So you can subtract 50. If it helps, draw your box and circle, and then subtract the circle from both sides, get the circle away from the box, and you get x equals 120 minus 50. Please make sure you use your calculators tomorrow on the test. X equals 70. So that missing angle, which is angle U, is 70 degrees. Okay, now you probably didn't, some of you didn't need to go through all that. You can just say, hey, I know that when you have the exterior angle and you have one of the remote interiors, you just take 120 minus the 50 and you'll get your missing angle, which is what we did here. So you can just put this in your calculator without showing work if it says not to show your work. Okay, now angle UVT. What in the world? There's 3 letters. That just means you start at U, hit V, and then go to T. So let's start at U, hit V, and then go to T. It's talking about this angle. Okay, can you find that angle? Well, we have a couple of ways to look at this. If we find that X is 70, okay, then we can change this to a 70. Then we have a triangle with 2 interior angles already given to us. So we can add these and subtract from 180. Remember, 3 angles add up to 180. So add these 2, subtract from 180. So 70 plus 50 is 120. And if you take 180, you can put this in your calculator. You can pause the video. 180 minus 120 is 60. So this is a 60-degree angle. Another way to look at it is, hey, I don't need these 2 angles. If I have this angle, this is a linear pair with this angle here. Linear pairs add up to be 180. So you can take 180 and subtract 120, and that's 60. Okay. So that's 2 different ways to look at it. The first way is to just, if you have these 2 interior and you got a triangle, then all you got to do is add these 2 and subtract from 180 and you get 60. If you didn't have these 2 angles, but you have this exterior, these are linear pairs with each other. You can, and linear pairs are always supplementary, which means they add up to be 180. So you could take 180 and subtract 120 and you'll also get 60. Number 10, you do need to do work. Like, there's no way around it. I would need to do work. So here, there's no exterior angle like this one. So we got to think about it differently. Think about, okay, what is being given to you? You're given 3 interior angles. An interior angle here, which is 90 degrees. Okay, the box means 90, okay? And then you have a 2x plus 1 degrees and a 5x plus 5 degrees. Well, you got to think about, okay, what can I do with this? If I want to solve for x, then I need to be able to write an equation. Okay, something on the left side, something on the right side. Well, is there a relationship here that you can use to set it up? Well, triangle sum theorem says the sum of the interior angles of a triangle always add up to be 180. So we're going to use that because we have all interior angles and we can sum them up. So I'll take one of these, 2x plus 1. I'll add it with one of the other angles, and then add it with 5x plus 5. And all of that added should end up equaling 180. Okay, so Now I have enough information to solve for x. I can't solve for x unless I have the equals there, and I have to have something that is equal to. In this case, this is a true statement, so I can use this. I'm going to go ahead and box and circle. And please don't get sloppy or lazy. Okay, you want to make sure you stay precise and accurate as you go with every step. You know what the domino effect that happens when you mess up one step. So I'm going to combine boxes first, not that you have to. 2x plus 5x is 7x. And I'm bringing it closer to the line because I know all this is going to get combined. So 90 plus 1 and then plus 5. 91 plus 5 is a 96 positive. I'll bring down the 180. Now I would again, oops, I don't want to make that look like a minus. So plus 96 and then 180. Now I don't have boxes on both sides, so I don't need to worry about boxes, but I do have circles on both sides. Which circle do I get rid of? Well, this circle is next to the box. Let's move it away so that we have the box on one side and the circle on the next. Inverse operation, you subtract 96. Well, whatever you do to one side, you do to the other side. These eliminate. You bring down your 7x equals 180 minus 96. Make sure you put 180 in your calculator first, okay? And then you subtract the 96. Because 180 is on top, you got to put that in your calculator first. Don't reverse it, okay? Because you'll get a negative, and that's not what you want in this particular problem. Negative answers are okay if you're doing the math right. So 180 minus 96 should be 84, okay? And then I would rebox and circle. And you have a box and a circle. Now go to the box. Let's get rid of the 7. How do I get rid of it? You divide by exactly the same number and sign. Don't do a negative here. Now whatever you do to one side, you do the same to the other side. I'm going to extend my line. I want my work to be neat all the way down. Okay, please make sure you don't rush through the test tomorrow, that you show your work. Okay, so then 7 divided by 7 is 1. So that 1 standing invisibly next to the x, which slips down. And then 84 divided by 7 is going to be 12. Okay, so again, check with your calculator, but this is your answer, and that goes here. Now, because I talked all the way through, it seems like it took a while, but really, if I didn't talk, I would say, hey guys, draw this picture on a separate sheet of paper and try it on your own again without looking at this at all, and see how fast that goes. Okay, it should take you probably less than a minute, maybe 2 to 3 minutes max. Okay, number 11. Okay, there's not going to be a problem like number 11 on the test tomorrow, but I want you guys to get used to problems like these because the interim or the Georgia milestone may have problems like these. Okay, in order to find this question mark, if you look at just this triangle, there isn't enough information. They just give me a 39, but I need at least 2 angles to figure out the third angle. So right now, this triangle doesn't have an information. However, if you look at this bottom triangle, look how it has 2 angles given to you. So I could figure out this third angle right here, okay? So we'll worry about this triangle in a second. These are connected, so we'll figure it out. Now, 20 plus 40 is, now remember, this angle plus this angle plus this angle is 180 because it's a triangle. If you're given 2, you can find the third. So let's add 20 plus 40, that's 60. So then subtract that from 180, and that's 120. So this angle is 120. Well, 120 is vertical angles with with this other angle here. So remember, vertical angles are always congruent to each other. So this is also 120. Now, in this triangle, I have enough information to find the third. I just needed to use the information for the bottom triangle to help me out. So now that this triangle up here has 2 angles that are given, we can find the third. So add these two. 120 plus 39 is 159. Take 159 and subtract from 180. So 180 minus 51, because these add up to be 180. So that's going to be, looks like 21. So this is 21 degrees, okay, this angle right here. It's a multi-step problem. You're using information from another figure to help you figure out, get some information for this figure that will help you figure out the answer. So it's multi-steps, but you guys need to be comfortable with that. And a lot of you are, so just keep that up. Let's go to this one right here. Oh, I'm seeing some exterior angles. I may need to use that, which means you come back to this exterior angle theorem. where you remind yourself remote interior angle plus remote interior angle equals exterior angle. Now I've got a couple of exterior angles going on. Don't worry about that. Like here, there's nothing really that is useful to us, but here there's an exterior angle, which means this interior angle you don't want to use. You want to use the remote interior angles. Now these, let's say we call this x. These two angles should add up to be the exterior angle, okay? So how do you find this other remote? If you use a calculator, you're comfortable, you just take this and subtract that and you got your answer. Or if you feel more comfortable writing this out, you can add x plus 45 equals 140. Now I need to subtract 45 to get it away from the x. Whatever I do to one side, I do to the other side. So I get x equals 140 minus 45 is going to be 95, okay? Remember, you do this top number minus the bottom number because that's the order that they're in. So this should be a 95-degree angle. So angle at E, or X, is 95 degrees. Okay, now, this is another three-letter angle. That just means it's telling you exactly where the location of the angle is. So if you start at E and then go towards C, okay, not this way because you'll hit D too soon. So you got to hit C before you get to D. It's talking about this angle right here. Okay, how do you find that? Well, if you already know, based on what we just did, you'd have to do this work, and you find that this is 95, then hey, you got a triangle. You can add these two up, 95, and then subtract from 180 to find that third angle. So 95 plus 45 is 140, and then if you subtract this from 180, you get 40 degrees for this angle. That's one way to look at it. Or another way to look at it is these angles are linear pairs. So even if you didn't have these two angles, you can say, hey, linear pairs are supplementary. I'll just take 140 and subtract from 180, and that's also 40. So there's two ways to look at it. Number 13. All right, so we need to find the measure of angle U, which has a question mark. Looks like we have an exterior angle, so which it's probably going to use exterior angle theorem. The remote interior plus the remote interior is equal to the exterior. Guys, if at any point it seems like I'm going fast, just pause, and then pause, and then pause if you need to. So let's go to this exterior angle. It's going to be equal to the sum of the two remote interior angles. This is not remote because it's right next to it, so we need to go to this one and this one. So I'll call this x. Okay, now some of you who are comfortable, you just subtract this in your calculator and you got your answer. Those of you that would prefer to write it out, you can say, okay, I know this remote interior angle plus this remote interior angle is equal to this exterior angle. So I can get the variable by itself, subtract 50, subtract 50, x equals 65. So looks like we found x, which is angle U, that's 65 degrees. Now to find angle UTV, let's say we put a question mark here, 3 letters means you start at U, go towards T, and then go to V. That means this middle angle is where that we're trying to find. Now, if you already know that x is 65 and you're confident that that's correct, you can put the 65 here and then examine this as a triangle. And if you look at the triangle, you've got 2 angles and you just need a third, which means, hey, I can use the triangle sum theorem, which says they all add up to be 180 to find this third angle. So since I have 2 already, I add them up. 50 plus 65, you can put that in your calculator and pause. It comes out to be 115. Then you take 115 and subtract from 180, okay? So that's going to be 65. All right, so this is another 65-degree angle. Turns out this is going to be an isosceles triangle since they have these 2 angles being the same. But that's just an interesting observation, okay? Let's go to the other side. All right, now, number 14 we didn't go over in class today, but I do want you to write this down at least, okay? Measure of angle 2, let's look at this. This is a typo. It should say 4 numbers 14 through 16. A is parallel to B, and P is a transversal. If the measure of angle 5 is 38.1 degrees, okay, then we need to find the measure of these other angles. Remember, if these are parallel, you're given one angle, you know every other one, okay? So given one angle, you can find all the other 7. All right, So let's see. Let's try finding measure of angle 2. Now, there is no special relationship between angle 5 and angle 2. They're not alternate interior. They're not alternate exterior. They're not same side interior. They're not same side exterior. They're not linear pairs. They're not vertical. But it's still possible to figure it out. It's just going to require a couple of steps. So, there's so many ways to go about this. You might say, okay, I'm going to give you one example, okay? But this is just one. So let's say, hey, I'm noticing angle 5 and angle 4, okay? We'll do this first, and then we'll do this. So let's look at angle 5 and angle 4. Ignore angle 2 for a second. Angle 4 and angle 2 have a relationship. Angle 5 and angle 4, we're going to figure it out. Now, you could go other angles and still figure out what angle 2 is, but this is one way that I'm choosing. So let's say angle 5 and angle 4, what kind of relationship do those have? Okay, those are alternate interior angles. Okay, now alternate interior angles are congruent. So if this is 38.1 degrees, then this is also 38.1 degrees. Now, if you know that this is 38.1 degrees, then you should be able to figure out what angle 2 is, because these are a linear pair. What do we know about linear pairs? Linear pairs are supplementary, which means they add up to be 180. So if you already have one of them, subtract it from 180 to find the other angle. So 180 minus 38.1, okay? If you put that in your calculator, it comes out to be 141.9 degrees. So this is 149.1. Let me correct that. 141.9 degrees. So let me just recap again, all right? We started with this angle 5. If we jump to angle 4, being alternate interior angles, we know that that's already 38.1 as well. Now, I'm trying to get to angle 2. Angle 4 happens to be a linear pair with angle 2. Hey, we know what relationship they have. They're supplementary, which means they add up to be 180. So, if angle 4 is 38.1 degrees, then you subtract it from 180 to find this missing angle, which is 141.9. Okay, so angle 2 is 141.9, but now it's time for the explanation. So let's see. Let's say we started with angle 5. You'll say angle 5 and angle 4, what kind of relationship do they have? Angle 5 and angle 4 are alternate interior angles, which means angle 4, which means they are congruent. So if angle 5 is, or here's a way to shorten it, if measure of angle 5 is 38.1 degrees, then measure of angle 4 is also 38.1 degrees. Okay? So let's think about it. Angle 5 and angle 4 are alternate interior angles, which means they are congruent. Okay? Don't forget, on your scrap paper tomorrow, you might want to say, okay, what's my supplementary? SSI, SSE, LP, those are my supplementaries, okay? All the other ones, vertical, alternate exterior, alternate interior, corresponding, those are all congruent. So right now we're dealing with alternate interior angles, which are congruent, okay? So they are congruent, which means they're the same measure. So if measure of angle 5 is 38.1 degrees, then measure of angle 4 is also 38.1 degrees. Okay, but now we need to get here. Angle 4 is also a linear pair with which angle? Angle 2. Linear pairs, I know this is long, but it takes this kind of longness, okay? Linear pairs are supplementary. Which means if the measure of angle 4 is 38.1 degrees, then measure of angle 2 is 180 minus 38.1 degrees, which is 141.9 degrees. Okay? And that would be an explanation telling us how you got 141.9 degrees. Now, number 15 and 16 we did in class, although in one class we might have only gotten to 1. 16 looks like 14, so this one's supposed to be a 1. So let's look at number 15. Number 15 asks you to find the measure of angle 3 given the measure of angle 5. So I'm going to use a highlighter just so that you can see we're dealing with angle 5 here and then angle 3. What relationship do those two angles have? Okay, well, this should be pretty simple. Okay, these have a special relationship already. The reason why we had to take longer on this was because angle 2 and angle 5 don't have a special relationship. It is not any of these. So we had to use double. We had to find one relationship and then another relationship to figure out what that answer was. It's a multi-step problem, which, again, you want to get comfortable with. So let's look at measure of angle 3. Thankfully, we're going to write less because these do have a special relationship. These are same side, okay? All right, these are same side interior, which are always supplementary. So that means, let's just think about it. If angle 5 is 38.1 degrees as given to us, and these two angles are supplementary, which means they add it to be 180, to find this missing angle, you're going to have to take 180 and subtract that. Okay, so let's do that. We'll start with angle 3. Now my writing here might be slightly different from what we did in class because often during class I'm asking you to give your input. So as long as it's similar, it's fine. So angle 3 and angle 5, I'm going to state that they are same side interior because I'm going to be using that relationship. So same side interior angles, which are always supplementary. Okay, why? Remember this. Same side interior, always supplementary. All right. Therefore, or so, if the measure of angle 5 is 38.1 degrees, then the measure of angle 3 is 180 degrees minus 38.1 degrees, which is, what is that? 140, yeah, it's also 141.9 degrees. Okay, so 141.9 degrees. And this one took a lot less explaining because we didn't have to do it double. We didn't have to do one step and then a second step. Here it was a one step. They already had a special relationship. So we're done with number 15. Let's go to number 16. Okay, now I'm going to focus on measure of angle 1 given measure of angle 5. So I'm going to look at 5 and angle 1. So these also have a straightforward relationship. I would draw a box and you will see that angle 5 is on the top left part of the box and angle 1 is on the top left of the part of the box. These are corresponding angles, and corresponding angles are always congruent, which means if angle 5 is 38.1 degrees, so is angle 1. So we're going to say, hey, this is 38.1 degrees as well. Why? We're going to use corresponding angles. So angle 5 and angle 1, or I've already written angle 1. So angle 1 and angle 5 are corresponding angles which are always congruent. Therefore, or so, if the measure of angle 5 is equal to, you can write that as well instead of the word is, they mean the same thing. If the measure of angle 5 is 38.1 degrees, then the measure of angle 1 is also 38.1 degrees. That's one way to write it, and that's it. That's all you needed because you wrote that they're corresponding angles, that they're congruent, and then you showed what the conclusion would be. If you look here, You stated that they were same side interior angles, what their relationship would be, and then you made your conclusion. Okay, here we had to do multiple. You had alternate interior angles, and you also had linear pairs. You connected them and then found your conclusion. Okay? All right, on to number 17. Now, again, if it confuses you, look for the angle, okay, and then the line that it's next to. Okay, it's next to this parallel line, and then this transversal. So if it helps you to like redraw those two lines without the middle line and then your transversal, then you can say, hey, this is in the bottom corner, so I'm going to put that right here, and this is in the like here, it's right here, the Y. Okay, then this is a lot easier to look at. Okay, so now if you look at this angle intersection and that one, these are an alternate interior angles. Okay, these are alternate interior angles. And remember, alternate interior angles are always congruent. So if you remember this, it'll help you a lot tomorrow on the test. They're congruent. All right, let's go to this one. This is pretty straightforward. No like extra lines going on here. If it helps you to draw your intersection, you can see that this Y is below this line to the right of the transversal. X is also below this line and to the right of the transversal. They're in corresponding positions. So corresponding and corresponding angles are always congruent. Okay, now this one, don't let this line here throw you off. I can tell already that these two are same side interior. If it helps you, highlight your parallel lines, look for only this transversal because that's where the X and Y are. If you want to redraw the parallel lines and then draw this one transversal without this one, then you can see that the Y goes here and the X goes here. These are same side interior. Okay, so same side interior. Okay, this is one of the SSIs, so if you look here, it's a supplementary. Okay, and last but not least, we've got angle X and angle Y. They're right along this transversal, so we're going to highlight this one, and Y is belonging to this line, X goes with this line. So once again, if it helps you to redraw those parallel lines, and then I'm going to just redraw this line here. The X is underneath it and to the right, and it's also to the right of the transversal and underneath the line. Hey, these are corresponding angles. Okay? Like if it helps you to draw the boxes, go ahead and draw the boxes. Kind of gives you an idea what's going on. These are corresponding because X is below the line to the right of the transversal, so is Y below the line and to the right of the transversal. So these are corresponding. A little bit more practice with corresponding angles, and corresponding angles are always congruent. Okay, so I finished this, but this is not the only thing you need to study. You also need to study the quizzes that I passed back today and the study guide. I will put on eClass all the things you should be studying, okay? All right, good luck, guys.